So we're actually work back and forth between Android Studio and Constraint Layout. So sometimes you'll see, oh, we're not making a lot of progress on Constraint Layout. That's because we're working hard on Android Studio. And to talk a little bit about Constraint Layout, Nicolas will give you a little overview.
All right, so first, where are we right now? We just shipped Android Studio 3.0. If you haven't updated, I highly recommend for you to update. We added a ton of things, specifically in the layout editor, lots of improvements. For example, the conversion from old layout to new layout is definitely much better, believe me. Plus, we support the new features we added in Constraint Layout. So definitely go and get it. Constraint Layout the current version stable is 1.0.2, which is starting to be a bit long in the tooth, but we are working pretty hard on 1.1. We released beta 3 2 weeks ago, and we are hoping to get beta 4 probably sometime this week if we can. And the idea is to get a final stable version of 1.1, maybe like within a few weeks, hopefully. Compared to 1.0, lots of improvements. Performance improvements, new features, but we'll talk a bit about that. So for hopefully the few of you that do not know about Constraint Layout, what is it? Well, it's something that allows you to set up positioning of widgets. The typical thing is you position it relative to another widget, and that should remind you a lot of relative layout, right? But the concept is very simple. You have something, you put it relative to another one, minus or margins. The one difference we have, the very, very basic difference, is that we can actually set up a position as a center between two anchors, meaning that it's not just a center in the parent, it's a center within anything you connect to. So you can be a center between two elements, center with, etc. The other interesting thing that you see here is that center allows you to set up a bias, so you can be, in some ways, more centered on one side or the other. But the combination of those two things, relative positioning and center positioning with bias, allows you to build pretty easily flexible UI that will adapt to your screen resolution. Another thing we support is the dimensional constraint. Like here I'm showing you the ratio, but basically we've got a couple of interesting stuff there. You can use the chains feature to, in essence, get group behavior. So often, it's not just that you want to position one element just on its own. It's more like you want to think about a set of elements and positioning them. The difference with chain compared to other view groups on Android, and you can, by the way, still use those other view groups inside Constraint Layout. But the advantage of chain is that it only works in one dimension, so you can do this group behavior only, for example, vertically, but do something completely different horizontally, and vice versa, which is something you cannot do if you are using a normal view group. The other advantage is that we keep the layout very flat, which has some nice properties in animation, which is the subject of this talk, so we'll show you a little of that. And finally, one interesting concept that we have is this idea that we can provide to you helpers objects, meaning that those things are objects that they won't actually appear in your screen. They are not here to, to show something. They are here to help you create and build your layout, your UI. So it's a way of helping you setting up all those complex constraints. And the one you see here is very useful. It's called guideline, and think about your designer talking about key line, red line, these kind of things like horizontal or vertical lines that you can set up to, for example, relative to one side or the other, or as a percentage, and you can build your UI based on that. Think about tabular UI where you want to have like a kind of a spreadsheet-like thing that was really difficult to do before, or you have to do grid layout or things like that. Here you just drop a few guidelines and you can build something. So in terms of the vocabulary, basically what is it that we support on Constraint Layout to express what a layout is? Again, you got relative positioning, you got center and bias, some dimensional constraints, group behavior, and those helper objects. And that's it. If you understand all of this, basically that covers Constraint Layout. Let me hand it to John for manipulation.
Now, there are two main ways you can animate with constraint layout. One is direct manipulation, and the other is constraint sets. And so first I'll talk a little bit about direct manipulation. So what am I talking about? You can actually just change parameters of the layout, and the layout will resolve itself, and you can animate. Typically, you'll use transition layout to do that. And so let's go through a small example. First, you'll take some object from the view, from the constraint layout, and you'll change some parameter. In this case, the simplest possible case I can think of is just changing the minimum height. Of course, before we do that, we do a begin delay transition. And so what does that lead to? If you were in a chain, you could see that the chain would actually rescale, and you'll notice subtle positioning and adjusting of everything as you select objects, because the chain is actually resolving its chain constraints while you're animating. And the begin delay transition is actually providing that interpolation so it's all smooth and elegant. So this is just one of the simplest examples. Let's look at another simple example. Use of GON. So essentially, if you use GON widgets, you can directly configure a view that is just going to disappear from the screen, and it will, and the rest of it will naturally flow and adjust. For more examples of that kind of thing, you can take a look at Hyun's talk from Chicago Rebato. There are some pretty cool examples in there. So a little bit more about guideline manipulation. Now, guidelines, as Nicolas just pointed out, is a very simple, you're just creating a line and positioning it. But that actually can be a very powerful element inside of your system, because you can hang a whole bunch of stuff off of that guideline, and all of that gets positioned by that guideline. And you can specify it in exact values or in a percentage value. So let's look at I don't know, strange. Let's look at a simple example. If we just create a guideline and we center an OK button on it, we put it up at 64 dips. So you do that all in your layout. Just position everything in constraint layout. You can do it in the GUI builder, as I've done here. Then you can get that guideline anywhere in the system. You get the end position. If you get it that way the layout is deciding where the ending position will be. And then you create an animator based on it. Animating from 0 to end. You have to do an update listener. And then you just change the layer parameter in the middle of it. Of course, you can then do other things with that. So you can change the duration. You can set a kind of a little bit more of a fun interpolator, the bounce interpolator, and then you just start the animation. Now, in the next release, we're going to simplify that so that the guideline will actually have a property, guideline end, guideline begin, guideline percent, so that you could actually do it even simpler than with just directly using object animators. But what would you get? Notice the OK button is bouncing in. So it's a simple trick, but now you've caught the user's eye because the OK button is just moved a little bit at the start of the right after inflation. So it's a very, very simple example. It's a quick additional 10 minutes of coding, and you've achieved a little bit of a differentiator in your app. Okay.
Okay, and so one thing that's interesting with guidelines is that you can think about it as a way of injecting values into your layout. So if you set up your layout with guidelines, if you modify the values of those guidelines, everything's going to move accordingly, right, to the constraint you set up. And we can use that to our advantage. So, you know, if you look at this layout, I got this big vertical guideline, you know, and all those elements, those images and buttons that are tied to that guideline. If I were to move the guideline, everything's going to move, you know, in a nice kind of parallax effect. So what I can do here is simply set up a touch listener and change the params like we saw before, but this time in reaction to a touch event. And if I do that, you know, I got this pretty nice effect where things move, you know, relative to the guideline direction. So, as I said, try to think about those things as potential input to your layout to parameterize your layout. So here's another example, a little more involved, of the parallax effect. And that actually works exactly the same way. You got here a recycler view containing, you know, normal layout with constraint layout. And the image here is actually bigger than the bounds of what we are showing, but it's centered onto a guideline. So this is what it looks like, basically. So then what you do is similar to the touch event, but this time through recycler view, you can add a scroll listener and do the same dance. Here, the math is a little more complex because I want, you know, to do interesting things with it, but that's what you get this really cool effect. What's kind of, and you saw like it works basically with the full recycler view, nothing special here. What's kind of nice as well is that because the only, all of that is programmed, of course, right? So you got, you know, compared to other way of doing parallax effect, here you are in full control. So if instead of having this particular effect, I want to have something a little different, it's as easy as here changing a minus to a plus, and then you got something that's more like a window-like behavior, which is kind of nice, cool effect. Constraint set.
Okay, so the second way of doing animations in the system is using constraint sets. Now, you can think of constraint sets as a container for all of your constraints. Think of it as the constraint layout minus the layout part. It's just going to hold all your constraints. It also has a programming API so that you can set values, get values. You know, you can manipulate the constraint set programmatically. You can also clone from live layouts or from XML files. There are three ways to get it when you clone. You can go from a actual resource file that's a layout, in which case it'll read all the values. You can a live layout, you just get the view and you ask it to clone. You could then also keep them as XML files, sort of separate from your layout, if you want to do that. Very few people seem to do that one right now. The key thing to remember here is that when you have multiple constraint sets, they kind of have to be representative of all the views inside of that layout, because when you go and apply them, it's going to go and try and set all the views. It'll throw a warning if there's a view missing that it needs to set up. So once you've done that, to set it, you just simply call apply to and give it the layout. It will sort of reach into it, set all the layout params for all the views. It also has a few other things that are not strictly layout params, like the Z value, the shift X, shift Y, things like that. But generally speaking, anything that kind of would affect the look of the view in terms of separation from the rest of the system, visibility, of course, things like that. So how would you use it? First, you're going to have to initialize a couple of constraint sets. That's pretty straightforward. You just new constraint sets. Typically, you create that at the top of the class. Then, typically on create, but it could be actually anywhere in your system, you will clone one, clone the next one. And in this case, one of them is already going to be on the screen because you just loaded it with set content view. The other one is not loaded because you're just referring to the layout. Once you've done that, now you actually have captured the two states. And for whatever reason you need to change the state, you just simply set, apply to, and the constraint layout, assuming you've captured the constraint layout as well, which you have. You can do this for many different reasons why you might want to do this kind of thing. It could be that you have basically the same UI, except a few views are missing from one versus another, so you want to set them visible, rearrange a few things. You can do a lot of different things. But in this particular case, we're going to talk about doing animation. So you do a begin delay transition. So let's look at just some very simple examples, and we're not going to go into the actual setting, but in this particular case, I've just created two layouts, relatively simply. One has a view up top, one in the other one the view is down below, and then when you click, it goes to the top. Notice the fade in pattern goes up and fades in. We'll discuss that more. So here's another one. You can imagine it where you want to show more details and you just change the state and bring in the more details. It's sort of quick, simple, very easy to build out UIs like this. Now, one of the things that you can do in this situation is you can change the custom transition. And you saw it yesterday. In this particular case, I've sort of made a copy of the auto transition that's within Android's framework. And I've just sort of copied it and made it my transition set. So essentially, I'm producing the same effect as I was producing before, but now I own the sequence. Now, let's take a look at some of the things this thing does. You see it's setting the duration. 1 second, it's duration in milliseconds. It sets the order to sequential, which means the first transition that you add is going to happen first, then followed by the second transition. The first transition in this case, actually contains two transitions that will occur in parallel. One is a fade out and one's a change bounce. So what that's sort of saying is, first, fade out and change and move the objects in the screen at the same time, followed by then fading in objects. So notice when the object goes to the top, after it goes to the top, contrast fades in. The word contrast fades in. But when it's going down, everything is moving while the contrast is fading out. So the sequence is very specific, and that's actually the default. But you can change things. So you can say, let them all happen in parallel. And I just moved it very simply. There are a couple of different ways you can do it. But you see the behavior of there's no post fade in of contrast. It's actually there at the start. And so you can choose to do lots of things. So in this particular case, I go get a little creative, and I just added a bounce interpolator. So it makes it a little more playful, and you can choose all manner of pattern. And there are lots of different examples of how you can adjust this. But this way, you have two layouts. You're switching back and forth between them, and then you're tweaking the look of it. But you can actually get really, really fancy. And if you look in this one, and it's too much code to show you here, but you'll see that this is bouncing around in various patterns. It's actually using the physics library to do its animation at the end. And you can do, I mean, literally, I've had goofier ones where the cards are flapping and all sorts of things you can do, especially with the physics animation as a sort of post effect, post-transition effect. So now.
Okay, so let's see another example of complex animation. So I'd like to have something like that, right? Like your typical collapsible toolbar. Although here, you may notice it behaves a little differently than usual, because actually this is using constraint layout for the app bar header. So how do we do that? So in your typical material design application, you can use coordinator layout, app bar layout, and the collapsing toolbar layout. All that works well, but it can be a little tricky to be more creative in terms of the animation you want into that header. So what I'd like here is to replace that with constraint layout. So you still keep coordinator layout, you still keep app bar layout, everything is still the same. You just replace the header with a constraint layout. All right, so if we do that, pretty easy, you got your XML, remove that, use a constraint layout instead. And probably use an include, just makes it easier for you to work in Studio. Okay, so that's my layout. Got some image in the background, some avatar, picture, and my name underneath. That's great. I got the constraints here are nothing fancy. It's it's a vertical chain for the two elements, packed and a little biased toward the top, and the image is simply filling the background. If I plug that, this is what I get. That's not exactly what I was expecting, right? Doesn't scroll, doesn't change, doesn't do anything. So that's not very difficult. If you played with app bar layout, you just need to add the right scrolls, flags, and exit until collapsed. And now it looks okay. It actually follows a minimum height, which is more or less what I want, but nothing changes into the layout itself. So let's go using constraint set and a little bit of Kotlin after. So as John explained, constraint set is great to basically set up two or more than two. It could be any number of variation on your layout, and that can be very, very different. So here I only want two states, but clearly you could go and use a lot more states if you wanted. Just wanted a very simple transition, but you could have like a 3 states header in the same exact manner. One thing you can notice here is that on the second constraint set, I do not have the image, because in fact, when you load a constraint set, you can only load the thing that matters to what you are changing, and I'm not going to change the way the image behaves, its constraint, so I can drop the image from the second constraint set. And what I end up doing is that for the first one, I put it into an open.xml file, for the second one in a closed.xml file, and then I can initialize them, read my constraint set from them, and we'll basically toggle between them. So that's the amount of code you need. And if I plug all of that, I toggle, while I'm scrolling, I'm toggling the different constraint set, and now we are starting to have something a lot more like what we wanted originally. So if I look a little bit more at this code, fundamentally, a couple of things. One, it's just a subclass of constraint layout. You don't need to make it a subclass at all, because the trick here is to re-implement the on-offset change listener of app bar. But you could do it outside of a subclass, obviously. But having a subclass is kind of nice, because I can just write my little subclass in Kotlin. It's neat, and I can just replace in the XML pointing to that, and everything will work nicely. So what I need here, one, implementing the change listener, basically here saying, hey, I'm going to listen for the offset change. And two, create the two constraint set that I'm going to toggle with. One thing here, and you notice that in John's example, we were initializing the constraint set in the onCreate. You can initialize them wherever you want. Here I'm doing it on the unattached window. And that's actually an important feature because that means you are in control of when you initialize those constraint sets, when you have to incur the penalty of loading XML. And then it's pretty straightforward. One trick here, we have to grab the offset, the vertical offset that app layout happily gives us. And here we simply set it as the top margin of the layout so that everything will actually collapse the nice way. Because if you didn't know, with app layout, the content of the app layout is not actually resized. As it looks like, it's simply scrolled up, but there is this vertical offset you can use to kind of squish the rest of the content. So by doing that, I can actually have this feeling of my header is collapsed. And that is simply toggling, depending on a flag, where I am, between the two constraint set, between the open constraint set and the closed constraint set. Relatively straightforward. So with all this plugged, we got this behavior. So that's nice, but we're talking about animation here, right, supposedly. And there's not that much animation. Sure, things are scrolling on screen, it's cool, but it would be nice to have a little bit of animation. And here, sadly, in all the previous examples, we're happily, using Transition Manager, because Transition Manager is great. You give it one layout, you change your layout, and it will automatically animate stuff. You can create your own custom transition set. It's cool. Apart that in this case, it doesn't work. I think it somewhat conflicts with app layout, not sure. So you can't use Transition Manager here, but you still have all this existing framework to do animation on Android with the property animations that we used a little bit before with the guideline example. So in that case here, I'm just going to create a little helper class in Kotlin, one where I'm going to remember my original position, and depending on if that position has changed or not, I can start an animator to move toward the new position, just using the translation X as a proxy. And essentially, this is what Transition Manager does, in fact, roughly. For the animating the background, because I would like the background to nicely fade out, it's actually very similar. We just use an object animator on the alpha channel, and that's all. So all together, the class looks a little more complex, but again, I just went through all of it, so it's not that complicated. One trick here is that I'm initializing my helper object that will handle this translation in the onLayout. You could initialize them wherever you want. If you do it in the onLayout, that means that the first layout is not going to be animated, which is nice. But if you wanted to animate everything, you could have initialized them on the onCreate or whatever. And that means that the first time they come on screen, they would have slide in. Beyond that, the only thing I need here in the onLayout is to call evaluate. So we got those, creation, and then I call the evaluate on those helpers, and everything will work. For the background alpha, it's actually, it went fast, but it's similar. I just need to call the alpha when I toggle the constraint set. And now, with all of this together, you can see that everything is animating and doing exactly what I want. And here, again, you got the advantage of, it's a little more complex in terms of coding, but you have a lot more flexibility into the final result that you are looking for. And again, you are not limited to two constraint sets. You could have way many more than that. So, summary for this section. Constraint layout and the constraint set gives you a lot of flexibility in how to express your layout, how to express those different situations that your screen can be in. You can piggyback on existing classes that the framework provides. Kotlin is very nice. And definitely, simplify your code. And Object Animator and all the property animation framework is still there. You can still use it. Let me talk a little bit about something different here. So we talk a lot about layout in general and constraint layout in particular, and the animation. And we got this concept with guideline as a helper object. And in fact, with constraint layout 1.1, and constraint helper, sorry, getting ahead of myself. So constraint helper is basically the class we are using to keep a list of views. You can think about it as a little bit as a virtual view group, because the problem we are trying to tackle here is that if you want to have an object that references other views in your layout, the traditional way of doing it is using a view group. But in the case of constraint layout, we don't really want to use a view group for doing that because, well, we would like to keep our layout flat. And the other thing is there's a lot of situations where you actually would prefer to not create that hierarchy because those elements that would be in that view group, you actually want them to be in more than one view group, you can imagine. Because you want to apply a specific processing, a specific treatment to that view, but you may very well do that multiple times in multiple effects that you want to apply. So we got this class, constraint helper, that essentially is going to keep track of referenced IDs and allows you to keep track of a list of views, all declaratively in your XML. And on 1.1, we are using that for two objects, two helper objects. One is barrier, that we didn't talk about, but essentially allows you to get out of a set of widgets the maximum or minimum of a position, which can be very, very useful. And the other one is group, which is just a very, very easy way of getting a group of widgets and applying an attribute. Right now, the only thing we support is visibility, but that's that still saves you having to do that programmatically. Here, you just in your XML can list your group. You can build it easily via Android Studio by dropping elements into the group. And then when you want to hide or change the visibility of a bunch of widgets, you just have to change the visibility on that group, and that's all. So very convenient. But how does that relate to animation? Well, there's someone Bartosz Lipinski that wrote this kind of cool small library that basically used this concept to apply a behavior. Here it's applying staggered transition on a set of widgets. So you can actually use those concepts to do this kind of behavior. And yet your layout is completely flat, you just control it. It's more about tagging a set of elements. Another way that we introduce in 1.1 is a concept of decorator. And the decorator is going to maintain a list of elements. So what do we do with the decorator? Fundamentally, it's just a constraint helper with a view. So the constraint helper, traditionally like guidelines, they don't show in your final hierarchy, right? They are just here to help you set up your system, but really they are not supposed to be part of the draw mechanism. But here with decorator, we actually want it. One advantage is that allows you to possibly gather a bunch of draw operations in a single place. The other advantage is to draw something that would be depending on multiple views position. And here is an example. So quickly the code, you have an update post layout that constraint layout is going to call, after we laid out all the objects, you say, oh, now is your chance to do something, and you can override the onDraw method. And fundamentally, if you think about the drawing, what we want to do is we start with a canvas. On top of that, let's say I've got my image views, and those are normal image views. There's no trick here. They are just widgets, they are views. The only thing here is that they don't have a background, but I'm just using the normal image view mechanism to draw them. They are just vector drawables. And the decorator is going to sit in between the canvas and those views. And here I'm just drawing red circles below them. And at that point, you should say, what are you talking about? This is stupid. The views can clearly draw their own background. Yes, but if you have this mechanism where the decorator is one object that can look at all those different views, you can get interesting effects like that. A little slower. And you can see that those are actually normal views. So just showing the bounds here. They're just normal view. You still have all the advantages of using views. It's just that you can do certainly a lot of interesting, cool special effects that were before very hard to do. Not going into the details of how to implement that, but it's actually fun algorithm. All right, let's sum it up. Basically, constraint layout allows you for a very flexible and declarative way of positioning your elements in your layout. You can directly modify those parameters to change and adapt your layout. The guidelines, it's a great way to parameterize your layout, specifically for animation, not just for screen changes. You have constraint set that allows you to manage multiple states of your layout, and that's an excessively powerful mechanism. You really should think about it as you don't need to have your layout instructions, the rules, they do not have to be tied to your view hierarchy. And I think that that's a really critical point that constraint layout allows you to do, is that you can really split up, hey, I need those views, but the way they are laid out is actually a separate problem. And constraint set allows you to encapsulate that, and because you can toggle and swap between constraint set, animation is a lot easier. Finally, a transition manager is going to do a lot of work for you, but of course, you still have the property animation, so you still have this really useful toolbox at your disposition. And finally, decorators, they are great for capturing this type of cross views, complex rendering effects. And that's it for the talk. We are a bit fast. Last thing, there is a bunch of documentation that you can find everywhere, on ConstraintLayout.com specifically, but on the developer.android.com websites. There's a bunch of Medium article, YouTube article, and John and I are pretty responsive in general. If you have questions or feedback, we are excessively happy to hear it. So don't hesitate.
Okay. Questions?
Yes?
Yeah.
The biggest issue we have had with constraint layout is whenever we need to have text in the lib size. It always tends to be that as long as your view still matches the constraint, it will not resize and it will just eat the text. It will leave the text with volume and put a huge text inside and it will just leave size everything, right? It's what's the workaround suggested for those cases? Because right now the only thing we do is request layout whenever we set the text. Because that's the only way we have to.
So if I understand the question, it's about if you have a text element in constraint layout and the text gets bigger, for instance, it doesn't react the way you expect.
Yes.
And I can tell you why. So the general idea is that constraint layout, when you measure an element, and specifically text, and text in general is what kills you in layout, because measuring text is very, very, very heavy. So one thing we do is that anything that we measure in constraint layout, we try to measure it as a single dimension and that's it. Specifically, if you are using fixed dimension or wrap content for your widgets, they are going to be measured only once, and then we are going to use that for the layout. Which in general, that's what you want to do because that's the cheapest solution, and most of the time that's going to work great. The problem is, in some situations, you do not want that because, for example, your text might actually kind of go beyond the constraints. But because internally we are saying, hey, the text is fixed, then those constraints stop mattering. So that's an issue. What we have actually we had a different way to handle that problem in 1.0. But in 1.1, we have a new attribute called constraint width equal true or false, same for height. And what that will do is says actually keep your wrap content dimension, and will start as a wrap content. But if you happen to run against other elements, then do enforce the constraint, which is exactly I think what you want to do. There was a talk. I gave a talk last week on at DevFest. You can find it online. I actually goes into some of the example where you want to use these particular things. Okay. Still not? Okay, then that's different. That's called a bug. And in that case, you need to talk to me.
Yeah. Contact us on Twitter is probably the easiest way to get it solved.
You showed support for using Object Animator with properties guidelines.
Yeah.
And you showed strings in there. Are there going to be constants for us?
Sure.
If you want, we'll put it in. Yeah, that makes a lot of sense. Yeah, we're gonna put it in and put out a release within the next week or so. Really, not sure exactly, but we have it in future development right now, and I just have to transfer the CL into the current beta.
Yeah, so the question was, it's great to have those groups with reference IDs, but the studio doesn't seem to know about them, which sucks if you want to do refactoring. Yes, but luckily we're working on it, so we'll add refactoring support for this.
Yeah, but it's not there right now. We know.
Also, you can't even command click on the reference IDs. They don't know anything.
Yeah, because I mean, it's sort of add-on to that we just piggyback on just a string and put these things in, and there is no deeper knowledge within the whole Android Studio world about those strings, and we're in the studio and we'll work on it. So, any other question?
Yeah, I noticed at one point you were updating that guideline and you were modifying the layout parameters, which from my understanding is actually going to trigger a whole layout measure pass every frame, right?
Yeah.
Actually, that's a great question. So the question is, we're modifying a bunch of stuff here via layout params, and you set the layout params, isn't that going to do a full-blown layout pass? And isn't that bad? And yes, in general, that would be bad, but actually with constraint layout, it's not that bad. Because we are, as I said, in general, what's costly is the measurement of elements. In that case, when we already did a measure and you are simply changing the layout params of constraint layout, we are not going to remeasure elements. So it's actually pretty cheap. The only cost here is solving the system, which we do pretty efficiently. So it's true that in general and with other view groups, that might not be a good idea at all. But with constraint layout, that's actually pretty okay.
Nice.
Yeah. Cool.
Oh.
All right. No more questions? Thank you.
Thanks.